you, Mr. Bonner, for the really good introductory presentation. So I'll be speaking about circular economy of wastewater, looking at from waste to resource. I'm Kangkanika Neog. I represent Council on Energy, Environment and Water. So we are a policy research organization, almost 7 years old now. We look into areas of energy access, renewables, power sector, and all these 7 verticals that you see here. Our work on water is under risks and adaptation. Just to give you a quick idea of the linear model of wastewater water use to the circular model. So currently what happens is we use and we throw, which is the linear model. But what we should push for and what is actually becoming a trend these days right now is the circular model, where we look at the circular economy model, which looks at reuse, recovery, recycling, and reduction. So when it goes from the source to process and to the user, there is efforts in reducing the amount of water that is being used. As you go from user to disposal, you also reuse certain amount. And then after you treat, you recover. So wastewater is very rich in resources. You can recover the water after treating. You can also recover energy in the form of heat and biogas, and also fertilizers. Also recycling, which is after treating, you send it back to the source, which is basically the ecological use. So this is what I'm going to talk about now. Just if you look at the case of India, is it even a case for a circular economy of wastewater? So all of these points have been mentioned today at various stages. I'll just quickly take you through them again. First of all, there is stress in water supply in India. So the per capita water availability has been decreasing rapidly. In 1951, it was 5,200 meter cube. Now it's 1,545 meter cube. And there is high spatial variation. Like you know, the Western Ghats or the Northeastern region has plenty of rainfall, whereas Marathwada, Vidarbha has less. Then you also see a case of deteriorating water quality. So in 2009, CPCB undertook this study where they looked at 302 river stretches around the country, and they saw that 91% of the river stretches were polluted. Also, this was also mentioned today morning about the criticality of the groundwater development. So 20% of the assessed groundwater blocks are either critical or overexploited. Also, if you look at the infrastructure that we have, 55% of our households still do not have any open drains. They have no or open drains. And also 65% of the generated sewage is left untreated. This is certainly more because 65% is probably just the capacity of the sewage treatment that we have. Also, demand for the resources that we can recover from the wastewater, does it have any demand as such in India? So if you look at this, 23% of our industries still do not get water easily or get it at a very high cost. Also, 30% of the global phosphate resources in India are imported by India. So this builds a strong case for circular economy for wastewater in India. So I see this not just as a challenge, but also as an opportunity. If we can integrate the circular economy of wastewater in our systems, we can improve water quality in the ecosystem. We can reduce the stress on the water resources by augmenting the water supply sources. And also we can add to the current resources of energy and fertilizers. So basically, these new opportunities will result in financial, environmental, health, and community-related benefits for different users of the water. So CEEW and 2030 WRG, Water Resources Group, we undertook a study late in 2016 where we tried to come up with a practitioner's guide which actually could help utilities to make a decision whether or not circular economy is feasible in that area or not. So we tried to connect global thinking. We looked at best practices around the globe and tried to connect it with the local Indian context. And we also made an economic feasibility assessment of treating wastewater to recover water, biogas, and fertilizer. Of course, the methodology, just a quick glance through it, we analyzed case studies across the globe. We looked at around 19 case studies. Then we interviewed experts who are already in the field working on wastewater and also tried to understand whether the factors that we identified from the case studies are actually relevant. Then using these information, we created a decision-making framework, which was particularly the practitioner's guide for the utilities. Then we also developed this MS-Excel-based techno-economic model, thank you so much, through which we could analyze, we could find out the tariff that this wastewater could be sold at. These are the location of the case studies that we looked at. So the ones in yellow are the case studies we looked at. So you can see a global spread. And we tried to see what are the uses of the wastewater, the treated wastewater that they were looking at. So most of this was for irrigation. Several of the case studies also used the treated wastewater for industrial purposes, and a lot of it was also for landscaping. As you can see, potable domestic water was only one case. I'll talk about that in the next few slides. If we look at the case studies around the globe, what is happening around the globe in terms of the circular economy model? The very foremost case which many people cite and which is very popular is the case of Singapore. So what Singapore did was, in order to augment their water supply, they produced this really high-grade reclaimed water, which is called New Water, and it now contributes to 30% of Singapore's water needs. So this water does not go directly for potable purpose, of course. It goes to the reservoir, it augments the reservoir, and then we pump it out for industrial purposes. Then in Namibia, which was very interesting for me, because this was the only case where I could read about direct consumption of treated wastewater. So they have been doing this for almost 30 years now. This is a very small plant of 21 MLD in Goreanga water reclamation plant. So these are the cases of water reuse. Now we come to Amsterdam West in Netherlands, where they are using the biogas from the sludge to produce electricity. Now they're using this electricity for their own electricity needs in the wastewater plant itself. They are also recovering phosphate from the wastewater. The case mentioned here is the case of California, which has been mentioned several times. So here, even Orange County, actually, they are reusing the wastewater, and it meets the needs of almost 500,000 people in the state of California. India, of course, also has a few very unique cases. For instance, the Kodangayur wastewater treatment plant in Chennai. What they do is the plant is based on conventional ASP process, and they use anaerobic sludge digestion and biogas utilization to produce power, to produce electricity. Moving ahead from just water, we also see that recovering energy and fertilizer is also taken to be a means of revenue. So in initiatives like West Amsterdam, Chennai, Southeast Beijing, so this was an innovative solution for them to their financial challenges. So they were basically able to reduce their operational cost by extracting energy, biogas, and phosphate fertilizers from wastewater. Similarly, I was talking about India being the largest, like 30% of the global imports of phosphate come into our country. So if we are able to capitalize on the available sludge that is available from the wastewater, we could reduce these imports, reduce soil and water pollution also, and subsequently increase farmer incomes. Like I mentioned, we also did this MS Excel-based tool, techno-economic tool, where we tried to take a combination of technologies and their cost, and we tried to see what could be the tariff for the water that could be resold to an industry. So basically, it helps analyze whether there is a business case for this intervention at all or not. The one on the right-hand side, if you look at that, this is the case of a 50 MLD wastewater treatment plant, and assuming that we sell only 40% of the treated water, we can charge the industry 31 rupees per kiloliter, and we can recover, the cost recovery is in 10 years. Now, why is this interesting is that, first of all, why did we even look at only industries? So industries are actually, they have a growing demand, but right now in our policies, the priority for water allocation is low for industries. So they also, if we could send water to them from wastewater treatment, it could be seen as a source of continual supply. Apart from that, in terms of water quality norms, the quality norms are less stringent. Also, there is less taboos about using wastewater compared to other sectors like domestic. There is better guarantee of payment, and most importantly, the current prices that they pay, the tariff that they pay for fresh water is higher than what I showed here, which is 31. Right now in places like Bangalore, they pay 50 rupees, Hyderabad pays 50 per kiloliter, Mumbai pays 49, Chennai pays 35. So in that case, if we can, in place of this fresh water, if we can sell them treated wastewater, the costs would definitely come down for them. And if we could by chance include energy and fertilizer recovery, the tariff that we should charge for the industries will come down even further. For instance, if you recover only water, like if I look at the red line, which is a 10-year payback period tariff line, if we recover only water, we have to charge 34.7. If we recover energy and water, we can charge only 30. And then water and fertilizer. The fertilizer recovery is a bit more expensive, so it comes up to be around 31. And this is the revenue share for 1 year, for the first year. 82% of the revenue collected would be from water, 11% from electricity, and 2% from MAP, which is the fertilizer, phosphate fertilizer. But in order to do this, we need the existence of supporting policies and regulations from the government. Globally, there are a lot of precedents. For instance, the PPA Act in Mexico, which is promoting investments in infrastructure. Then the Code of Good Agriculture Practice in Cyprus, and the National Water Strategy and the Green Morocco Plan of Morocco. However, the existence of these plans, these policies and regulations should be supported by stringent implementation. In India, we do have a couple of precedents set by the government. For instance, the 2016 revised electricity tariff notification, what they said was thermal power plants which are situated, including the existing plants located within 50 kilometers of a STP, should use water from the STP for its cooling usage. We found that if we are able to do that, we will be able to support substantial amount of additional electricity generation. For instance, if the treated wastewater from all the operational sewage treatment plants, it could meet the water demand for additional 53 gigawatts of thermal power in 5 Indian states, and so on. So a circular economy of water has the potential to reduce water withdrawals for power generation, while also at the same time increasing the economic returns for urban water utilities. Another important policy, the MOU which came up, was in 2015. It was signed between the Ministry of Railways and the Ministry of Water Resources. So there they agreed that they are going to use, Ministry of Railways is going to use the water from the STPs come in the Yamuna and Ganga region for the various purposes, non-potable railway purposes. So these policies should actually be seen as precedents for making circular economy of wastewater a mainstream option in the country. Now we spoke about industrial. Let's go to industrial use. Let's get into irrigation with untreated wastewater. What happens currently is in the peri-urban areas of the country, they have no choice but to depend on the untreated wastewater for their irrigation purposes. Now, this also has a lot of negative externalities. One study found out that the annual health cost per child in untreated wastewater irrigated environments in India is around INR 4,000 per annum, which is 73% higher than the annual health cost per child in freshwater irrigated areas. So definitely there is a negative externality in terms of health. Australia sets a very interesting case here, where in the Virginia Irrigation and Water Cycling Scheme, they send the reclaimed water to 400 connections in area in and around that water reclamation plant through a large network of pipes. Now, however, irrigation is, again, we spoke about industrial and irrigation, but when it comes to domestic, of course, it's still a taboo in the country. But it's probably time for us to talk in terms of breaking these taboos through advertisements or through proper capacity building methods. So what Israel did while they were going through a lot of trouble in terms of water resources is that they invited models and actresses to come and speak through a nice video advertisement. Now these sort of activities helped to reduce 10 to 15% of the water consumption. The thing which Singapore did while they were inaugurating new water was that they started using used water and not wastewater. They started using water reclamation and not sewage treatment. So use of positive terminologies for treated wastewater is also important. Like you mentioned, Mr. Bodner, about Water Resource Center. Things like that. How can we create a enabling environment in the minds of people by changing a few terminologies? Can we stop using the term wastewater, although it's very difficult right now? Then apart from these technical solutions, these financial solutions, we also need to create an integrated environment in terms of the governance. So there has to be divided responsibilities among stakeholders, but at the same time, there should be harmony and coordination among them. So encouragement of stakeholder participation can probably be mandated through comprehensive contracts. The private sector would then may take the lead in operational management, while the government should be able to support through their expertise. The government will have to take lead in reforming financial strategies to meet the cost requirements of running these treatment plants. And the third-party and independent third-party audits should be done annually, and public feedback mechanism should be in place. A few takeaways from this study and from this presentation. So we were able to establish that there are direct benefits through recovered resources from wastewater, and it could make an economically attractive cases for practitioners to manage wastewater. While we saw that in most of the cases, water scarcity was the main driving reason why the reclamation and the circular economy came into being, we should also remember that sustainability principles should ideally be the driver. So basically, even if you don't have any water resource problems, this could go a long way in reducing the problems in the future. Basically, a stitch in time saves 9. A proactive approach and leadership from the government and public sector would be essential for the success of this initiative. Utilities, local governments should integrate water and wastewater management instead of treating them as separate entities. And NGOs can now take up the opportunity to influence public at large about the benefits of such intervention, as a result to tackle the taboo around wastewater use. So I would like to leave you with this thought. Can Namami Ganga, which is now looking at sewage treatment plants, not just look at sewage treatment plants, but also look at water reclamation and make this option of circular economy more mainstream? Thank you.